except for the ones that we did.
Are you doing a ceremony for it?
Oh no. Oh no.
You know, she told me to be really mean to you the other day.
Call him here today.
Okay, I'll call on her multiple times today.
Then why do you have a water?
Pre-college, read.
Read?
Read.
Read?
Pre-college
Nobody likes to
program.
read.
You had to read for UW Oshkosh?
Who likes to
No,
read?
It's a pre-college program. I had to go there because New Scholars requires a pre-college program. And I went there, and it was the worst time of my life.
Imagine being a New Scholar.
I don't even do anything. I got a strike or whatever it was. Because I'm not filming and I'm not doing any of the assignments. And my mom doesn't care because she thinks it's a waste of time.
It
That
is
is
a waste of time. You only get like
James?
$5,000. You
Yep.
can get a heck of a lot
No,
more.
you only get $5,000 if you do every single assignment and appear every single day. Like, all that work for $5,000.
You can
And the
get
thing is,
so much more for doing so much less
Yes.
than getting other scholars.
And some people are like, but it's just like free money. And like, it's too much of my fucking time.
It's not free if it's that much work. It's like doing.
And it's
It's
$5,000.
like working 10 years to just get to the very end of $5,000.
$5,000. Like, bitch, don't tell me that it's so easy and it's not even that much. What are you gonna do with $5,000 in college? Right.
Pay for one class.
Right.
Good Monday morning, ladies and gentlemen. One of the last 2 times I can say that to you this year.
What good?
Oh no. Is everything else pretty bad?
No.
Oh, this year.
Yeah. There's only one more Monday that we will be together this year after today. That isn't what I said, is it? No, I didn't think it was what I said.
Everybody refers to the school.
Whoa. Me and everybody don't get along.
Most people.
Most people and me
normal
don't get along. And normal has never been an adjective that has been used to describe me. Thank you very
We can
much.
tell.
So, get logged in, ladies and gentlemen. Get a calculator. Haley and Kaylee. Let's go. Look at that. The leads. Haley and Kaylee.
My computer's
Bring your periodic table. Bring a calculator. Bring something to write with. What?
Stop.
Stop what?
Stop doing that.
I'm not doing that.
Okay, 1 plus.
Dude, I don't care about whatever this is. I don't care about whatever the fuck it is.
He doesn't want to learn how to use his calculator. You can lead a horse to water, but you can't make him drink.
Yeah.
Which one's the useless button?
This one.
Four?
I've never seen it.
Well, that means it's got to be useless. Because if no,
Would
you're
it be
mighty
funny if I
17
had
years
this
of
little
age.
old lady shove it
I don't
into
know
the
why
ground?
What?
Would it be funny if I had this little old lady shove it into the ground?
Yeah.
Like a middle aged woman.
How my nose is messed up.
You're almost there.
Like, extremely messed up. I'm gonna die.
That's unfortunate.
It is. Genuinely. Ew, I hate smoking. Sorry.
I'm fine. It's not a problem.
Speaking of apologizing, how many times did you yell at my sister apologize?
Yes, it does.
How do you know?
Because I apologized. Mikey kept saying sorry, and I said push up.
Give me a-
And then
You said sorry for being in pain.
Yes, look, smell this.
Oh, that's
I know how much.
Hey,
Give me a crime that somebody might have to do in order to survive.
Every,
what?
Give me a crime that somebody may have had to do in order to survive.
yeah.
Steal food? I don't know, bitch.
I did not think you were going to say periodic table.
You can do any crime. I mean,
No.
no.
There are like.
There's
I mean,
crimes I
okay,
did not do.
Let's take The main character murdered people in order to earn more money to feed herself.
Ow. Sorry.
Brooke said owl. But they don't excuse terrorism. They don't excuse the overtaking of the government in order to commit acts of terrorism.
Well,
I'm just gonna say that he's a bomber. He bombed. a place.
terrorism is bad.
Is it though?
Ew.
Ho! Righty-tighty, tighty, ladies and gentlemen. Here we go, here we go, here we go.
I hate this backpack.
Question number 1, ladies and gentlemen. Take this ratio that you got from calculating an empirical formula and write and name the compound. Formula and name of the compound. Let's go. Ben, I'm sorry, I should have told you we needed our computers out today.
I guess I just wasn't listening.
What's that?
I guess I just wasn't listening.
What's that? No Dante today? Yes. I mean, that's too bad.
No, there's one less. It's 3 oxygens. No, you divide the number into 2. Because that's the charge. It's like C.
All right, ladies and gentlemen. Anytime you see 3 elements in an empirical formula, and one of them is a metal, what does that mean? There's a ternary ionic compound. Okay? Now, also, when one of them is a metal, are metals ever involved in our polyatomics?
No.
Not normally. There are a couple that do. Chromate and dichromate, for example, you Cr chromium, that is a metal. But you have to ask yourself, which 2 of these 3 are involved in the polyatomic? Calcium and iodine, or iodine and oxygen? Which 2 are involved in the polyatomic? Iodine and oxygen. These are the 2 that are involved in the polyatomic, ladies and gentlemen. Okay? Now, I know it says 2 and 4 here. When you look on the back of your sheet, you're not going to find a polyatomic involving iodine and oxygen with a 2 and a 4 in it, correct? So what's the closest you find? You find IO2? IO3. But this is obviously not IO3, correct? What would this be? IO what? 2. Okay? So how come the 2 and the 4 here? Because there's 2 of those groups here, ladies and gentlemen. Okay? Please remember, all an empirical formula can give us is what is in the compound in its lowest possible terms. And this is absolutely correct. This is what is in there in its lowest possible terms. But calcium has what kind of a charge? Positive how much? Positive 2. And this iodate has a charge of what, or iodite, sorry, ITE ending, has a charge of what?
-1.
-1. That's why we're ending up with the 2 here, ladies and gentlemen. That's why we are ending up with the 2 here, okay? So, if we take this and we show you its formula, it's CaIO2, 2. Why? Calcium is a +2, so we need 2 of these -1s to balance it out. And the name would be calcium iodite, ITE ending. Because it lost 1 oxygen. Iodate is IO3. This is lost in oxygen, and it is IO2. Questions? Okay, tell me what the formula for this one is, ladies and gentlemen. Formula and name. What do you notice that's different about this one, ladies and gentlemen?
That it's not like a polyatomic or the ones in the back of the periodic table
Why?
because they're non-metals.
All 3 are nonmetals here, right? All 3 are nonmetals. Now, I have never taught you how to name a compound with 3 nonmetals, correct? Well, actually, I have.
Ammonium.
If you have ammonium. If you have NH4. What do you notice about N2H8? It divides on back to NH4. So again, this is your polyatomic here, ladies and gentlemen. It is one of the very rare ones where the polyatomic is a positive ion. But it does happen occasionally. So this is our NH4. Now, why is there 2 and 8?
Because sulfur is a -2.
Sulfur is a -2. NH4 is a
+1.
+1. So again, ladies and gentlemen, we end up having NH4 in parentheses. We put the 2 outside. That would double the nitrogen and the hydrogen to give us this 2:8 ratio. And again, because sulfur has a -2 charge, that's going to put the 2 down here. +1 is by the sulfur. Okay? So again, I know it isn't easy, but we can reason through these, hopefully, when you're on your test on Friday, because there are a few of them like this on your test on Friday. Questions? Oh, by the way, Kaylee suggested we have a test on Friday, so we're going to have a test on Friday. Okay?
I thought it was because every 3 weeks we have a test.
No, not always. The first trimester we didn't.
You said this trimester?
Yeah, I'm going to try to be a little more consistent because I know you guys complain all the time about how inconsistent I am. So I'm going to try to be more consistent this time. Okay? Questions? Okay. So try this one then. BA 1.5, AS1, 05. Okay. What's unique about this one?
It's like arsenate, but again, 1 oxygen.
Okay, that isn't what I was thinking, but how do you know that? Can I ask?
Because in the back of our periodic table, arsenate is ASO4.
Okay, good. So we're starting to turn it over. We're starting to look at the back of the periodic table. Okay. Why do you know it's ASO and not BAAS?
There's no such thing as that in the back of our.
Okay. And another reason is because Ba is a what? Metal. The only polyatomic I have given you to start a compound is ammonium, beginning with nitrogen, right? So this is Ba, it's a metal, okay. Agreed, okay? Now, I like what you're thinking, Ruby. ASO4 is our normal polyatomic, right? Well, this ends up being ASO5, 1:5 ratio, correct? Okay, we can still work with that. But again, what was unique about this one compared to the last couple? Alex.
For barium, there's a 0.5. Which
Okay.
to make it whole, you have to times it by 2.
Thank you. Here's the thing, okay? We can do rounding. Absolutely no problem with that. If you went around 1.9, we want to round that up to 2. 0.21, we'll round that down. But if we get to 0.25, a quarter, that's a little bit too much rounding. Now, I don't think I ever give you one with a quarter. There might be one on the worksheets, not 100% sure. But I normally don't give you one with a quarter. But you might get one with a third, 0.33, 1.33, which means then we're going to need to multiply by 3. If we got 1.5, we need to multiply by 2. Why? Because all a ratio will ever do is make it so that the smallest number is 1. But it is possible that you could end up with a 1.5, a 1.33, a 2.33, something like that. Now we're going to have to adjust. Okay? Thought I heard somebody knocking. Oh, sorry. What?
Would barium be 3 instead of 1.5?
Well, we're going to have to double everything here, correct? Okay, so we're doubling everything. So this becomes 3, this becomes 2, this becomes 10. But again, is there one that is AS2O10? No. So what does that mean when we double this? What are we going to have to do? Huh?
Well, no, sorry.
When we double this, what happens?
Parentheses and then 2.
It ends up being the number that goes outside the parentheses like on the last few. Okay? So we end up with BA3, ASO5, like you had said, Ruby, and then we put the 2 outside the parentheses. Why? This has a -3 charge. This has a +2 charge. Our charges are still balancing out. Okay? Our charges are still balancing out. We've got a polyatomic involved. We are all good here. And the name would be barium perarsenate, not changing the A to E, but putting the per in front, indicating it has gained 1 oxygen. Questions? Okay, I wrote the test. It's in being copied. I think I made a typo on it, but we'll live with that. Okay? Your test on Friday is 9 questions, not including the bonus. 73 points. You will have a problem where I give you ratios like this, and I ask you to give me the formula and the name. Okay? Okay. So that is going to be on the test. There are going to be, on the quiz that I am handing back to you, there is going to be a problem like each question on this quiz. Now, actually, there will be multiple problems like the first one on this quiz. Like the second one on this quiz, where you will have to convert from milliliters into atoms, grams into milliliters, particles into liters or grams, things like that. There will be 4 of those problems on the test. Those are worth about 6 points apiece, ladies and gentlemen. And then there will be 3 major problems. One like is on the top of this quiz where you have to find an empirical formula. Okay? And then I'll explain what the other 2 are going to be like by the end of the hour today for you, just so you know. So when you get this back, overall, ladies and gentlemen, I was quite pleased with the results on your quiz. You guys are doing very well on this. Some minor mistakes, though, especially on the second problem, ladies and gentlemen, that have led to a little bit of confusion that I'd like to clear up for you. Okay? So we will go over this in just a moment here. All right. Again, overall, most people did pretty well. But again, here's the other thing. I can't grade what you don't show me. So if you're not going to show me work of how you go from here to here, you have to somehow explain it to me. Because I need to know how you get to these final answers. I need to know that you're not just pulling numbers out of your butt and hoping they're correct. So if you do it the way I set it up, that is absolutely fine. If you're not going to do it that way, you need to find a way to communicate to me why you're doing what you're doing somehow. Okay? So, ladies and gentlemen, we have two versions. We have version A and B. So please make sure you are looking at the correct version. The problems were similar, ladies and gentlemen. Okay? The problems were similar. And here is A and B. A on the top, B on the bottom. So you're going to take the masses that you were given in each of the problems and you are going to get them into moles. Anytime you go from mass to moles, it's a 2-point conversion. 1 point for setting it up right, 1 point for using the correct formula mass. If you're not showing me that, I'm not giving you 2 points for it. I'll give you 1, but again, there's no reason for you. You have to show me why you're dividing or why you're multiplying by something. We then get the moles for each. Okay, gave you a point for showing me that. Then I gave you a point for knowing that you divide by the smallest one, and 1 point for calculating the actual ratio. Then I gave you another point for the formula and another point for the name. And that's how I got 13 points on this problem and 13 points on this problem. I know it says 14 here and here. That is incorrect. Okay? Questions? Move this so that it's out of the way. Any questions at all on the first problem? Okay. The second problem, most of you got it correct until the very final step. In both cases, the compounds in both cases are molecules. But this one's N2. This one's CO2, still a molecule. Okay? So when they ask you to go from milliliters to atoms, atoms are not the smallest part in here with the 6.02. Molecule is. And most of you went from milliliters to liters. By the way, you don't have to show me that. That's the one that I will give you if you don't show it to me. But you need to somehow show me that this is 0.975 liters then. Okay? If you're not going to show me doing the step, you can just do the math and start out with 0.975 liters. Then we use moles over liters to get to moles. Then we use molecules over moles. And molecules is the proper unit here because this is a diatomic molecule. This is a molecule. Okay? But then the last step, to get to atoms. How many atoms are in this molecule? Well, there are 2 atoms in this molecule. There are 3 atoms in this molecule, CO2. And that is the last step. The smallest piece is not atoms. The smallest part for particles is molecule. We then need to go one more step beyond that. Okay? And that's how we get to these numbers here and here, ladies and gentlemen. That's how you got all 7 points on that last problem. Questions? Yes, no, maybe so. All right, ladies and gentlemen, those are yours to keep. If you have questions on them, if you think I graded something wrong or unfairly or want to talk to me about it, I am here before and after class every day. I'm here every morning before school, and I'm here just about every day after school. Be more than happy to go over things with you. Okay? All right. Questions? My gosh. This might be a first, ladies and gentlemen. I made a third copy of the quiz, and I'm not going to need it because everybody's done and taking it. Yes, Michaela.
I'm confused on one part of this. How did I get
Well, because that was all the points that it was worth.
Oh, it's okay. Okay, never mind. I was like, why
That's
does it
why.
say 14? I was looking at the one.
No, it did say 14 up there.
Yeah,
And
why is it
that's
different class?
no, it's just I didn't update the information on the question there. Yes. So yes, it had the wrong numbers on there. I had the right numbers on there. Okay. Good. Questions? Other questions? All right. So today, ladies and gentlemen, we have the last part of our mathematical computations to do. And if you're wondering what the heck that means, ladies and gentlemen, that means that this is the last mathematical part of this unit. After that, there will be a little bit more where we will talk about something we've actually already talked about using the backside of one of our other sheets. Okay? To know if something will be a precipitate, a solid, or if something will be aqueous. But we do need to go through one last thing, and that is we need to go through something called percent composition. So if you would, in your EISN, ladies and gentlemen, open it up to the slide that looks like this, finding percent composition, ladies and gentlemen. Now, this is kind of the opposite of what we've been doing. We have been using percent composition or the amounts of each component to figure out what the empirical formula is. Now we're going to go backwards, ladies and gentlemen. And the good news is I think this is easier because we all know that a percent is actually what? What is a percent?
A fraction?
Kind of. I always thought they were a percentage, but they come from a fraction, right? Okay, that I will give you. When we find a percentage is always a what of the what?
Part of 100.
No, but you're close. No, you are very close. I'll give you the part correct. It is part. It is not always of 100. It's part of a whole. The whole doesn't always have to be 100. Now, your percents need to total up to be.
I don't want to say.
Why? Because why?
100.
Yes, they do need to total up to be 100. But when we're talking about a part out of the whole, the part nor the whole needs to be 100. What we get in a total needs to be. Okay? So I'm going to ask for a favor. I want someone to name me any ternary ionic compound they wish. Give me the name of any ternary ionic compound, ladies and gentlemen. Don't all shout them out at once. I just need one. Go ahead. Let her fly. Yep, thank you. That'll work. Go ahead. Good, good. No, I need one. Come on, pick one.
What was the question?
I want the name of any ternary ionic compound. I'll even write the formula for me if you just give me the stinking name.
Calcium di. That's not.
Oh, he still could save this yet.
Dichloride.
And he fell off the cliff at the end. Go ahead.
Calcium phosphate.
Calcium phosphate. Now, you could have saved it by using dichromate, James.
Oh, yeah.
Dichloride, now you're mixing our two naming systems.
Oh, that's what I was doing.
Yeah, that's what you were doing. By the way, calcium phosphate would have a formula Ca3PO42, correct? Yes? We're agreeing?
Yep.
Okay, good. All right. So tell me what elements are in calcium phosphate.
Calcium, phosphorus, and oxygen.
Okay. Now, tell me the mole ratio. How many calciums?
3,
How many phosphorus?
1,
How many phosphorus?
2,
How many phosphorus?
2, 2.
I wanted, you went 1, then you went 2. I wanted to see if you'd go 3. Okay, how many oxygens? 8. Okay. Questions? Okay. Now what I want is I want the mass ratio. I want the mass ratio. How do I find the mass ratio?
Formula mass
Of what?
of each of the elements.
Okay, so what's the formula mass for calcium, James? I'll save you some trouble, 40.08.
Thanks.
Which we are then going to multiply by how many calciums there are, which is?
3.
Which gives us a total of 120.24 grams. Technically, grams per mole. We'll go easy here. Everyone see where we got that from? Okay. What about phosphorus?
61.94 grams.
Well, how'd you get that?
What do you mean how I did it?
How'd you get that?
I did 2 times 30.97.
Okay, which is 61.94, correct?
Yes.
Grams. Okay, perfect. Now what do we do for oxygen?
16 times 8.
128.0 grams, correct? Okay. Now, here is the reason, ladies and gentlemen, that we do not use mass ratios. Who's got a calculator handy? Good, all of you do. Okay? All right. Look at our mole ratio, 3 to 2 to 8. Those are all what? Whole numbers. Real easy to find, real easy to see, correct? Okay. Take 120.24. Ruby, 120.24 divided by 61.94. What do we get? Ben, 61.94 divided by 61.94.
She just said it. You interrupted her while she was saying it.
Ben, she's giving me a different calculation than I'm asking you to do. 61.94, Ben, divided by 61.94. I can't believe he's using a calculator. Go.
Oh, I thought you wanted to do the same thing.
1.94, 1, 2, 3, 3, 4.
1.94.
God damn it, James.
What was yours?
1.
Good. Now, 128 divided by 61.94.
2.06.
Okay. We don't get as nice a ratio, do we? We don't. There's still a ratio there. I will tell you, mass ratios are not even close. Last hour they picked a different compound. We had 1.68, 1.42 to 1. We can't just round those either. Okay? So the point is, the reason we use molar ratios in formulas is because these come out to have to be whole numbers. Mass ratios would not. Mass ratios would not give us whole number ratios. Okay? So we don't use mass ratios, but there is a mass ratio here.
Oh, it's okay.
There is a ratio of masses in this compound, correct? So these are the what in percent composition. This is the what of this thing.
The elements?
No, what'd you tell me a percent was just a few minutes ago?
Oh, part of the whole.
Part of the whole. So these are the what? These are the parts. Where's the whole? Right there. Right? These are the parts, the things that make up this one thing, correct? So here's the mass of each of these things, correct? What do I still need?
Would it be like the percentage of each?
Okay, I do need the percentage of each, but before I can calculate that, I've got the parts. What don't I have? Thank you, Haley.
that one number that you get.
That one number that you get.
After dividing the
Why
lowest
are we
number.
making it so hard? We just gave the answer 2 seconds ago, ladies and gentlemen. These are the parts. I've got the mass of the parts. What don't I have the mass of?
Of the equation. Of the whole. The mass of the whole.
Thank you. I don't have the mass of the whole thing. It's parts in the whole thing, right?
That's why you add them together.
Add what together?
The parts.
Okay, good. Add all the parts together. Haley?
What?
Here, this is for you. Because you're special. Careful, don't trip over the cords that people are trying to kill you with. Huh?
310 pounds.
310.18. What? 310.18 grams? Okay, so now we got the parts and we have the whole. So we are going to find out of this compound how much of it is calcium. And we do that by taking the part divided by the whole. And then what?
And that's it.
No. Your math teachers would be just rolling over in their graves right now if they were dead.
3.
What?
Multiply it by 3.
No, Mike, why 3?
Because it's the amount of moles that are in there.
No, this has nothing to do with moles.
Sorry.
Nothing to do with them. How do you find a percentage?
I'll multiply by 100.
Thank you. Oh my gosh. What? What? I didn't hear you. I'm sorry. What'd you say? Okay. So we are going to take 120 point.
38.76.
Slow down, Speedy McFinger calculator girl. Divided by what? 310.18
Times 100.
times 100. What do we get now, Speedy McCalculator girl?
30.76.
I'm only going to the tenths. Why? Because there is nothing in here to indicate the what?
The precision.
Nothing in here to indicate sig figs. We didn't measure a dang thing. So my suggestion is go to 3 sig figs in your number. Or go to the tenths place. I don't care. Either one.
Wouldn't the sig figs be the mass ratio though?
No. Because those are infinitely significant because those are known values to that particular element. They're like conversion factors. Okay? Point being, don't get caught up on sig figs here. Just go to the 10th place. Fair enough? Good. Excellent. Wonderful. That was for calcium. Now we need to do the same thing for what?
19.96.
For 19.96. Does anybody know what 19.96 is?
Is 61.94.
Why are you doing that?
What do you mean?
Well, we did this for calcium. What do we do next?
Phosphorus.
Okay, we do that for phosphorus. So let's, for phosphorus, take 61.94 divided by 310.18. Same number on the bottom, right? But now, unlike before where we were dividing by the smallest number, now we're dividing by that one.
By the whole.
By the whole, which happens to be the what kind of number?
Largest number.
The biggest number. Then we're going to take this times 100. What do we get?
19.96.
9.
19.9. No, actually, not 20. You got 20.
Yeah, now she realizes why I'm upset because now I got to erase this and write the right number down because she wouldn't give it to me the first time. 20.0%. Then we do the same thing for oxygen. 128.0 grams divided by 310.18 grams. Look, units even cancel out if you wanted to do that. Times 100 equals
41.26, but it's 0.3.
whoa.
Whoa. Does that mean that
38.8 plus 20.0 plus 41.3. What does that equal?
100.1?
And that is absolutely totally okay in these problems. Now, why is it okay to come up with 100.1%? Because we went the extra yard.
Because we rounded up.
Because we did rounding. And when you do rounding, when you get to this 100% total in the end, you may end up with 99.8. You may end up with 100.1, 100.2. It is okay. We are fine. We can do that. Question. Good? By the way, 9-point problem on your test. 3 questions on your test are worth 40 of the 73 points. 3 questions. Okay? Questions? Okay, let's go through a couple more practice ones for you, ladies and gentlemen, before we tell you everything that's on your test. All right. I suppose it would be important to mention, ladies and gentlemen, what are your chances of doing percent composition correctly if you can't write a formula?
0.
Probably less than that.
Okay.
Probably less than that, but you're absolutely correct, Haley. Probably no chance, okay? So you better make sure you get your formulas right. So when we say magnesium nitrate, you better know that the formula is...
Magnesium nitrate.
Right, the formula is magnesium nitrate, Mr. Brand. Just write it down for us, please. Go ahead. I know you're going to give it to me on the test. Wrong answer. MgNO3 in parentheses 2. Perfect. Now, the formula mass for Mg parentheses NO3 2 happens to be 148.33. How do I know that? Because we have 1 magnesium at 24.31. We have 2 nitrogens at 14.01 making up 28.02. And we have 6 oxygens at 16 making up 96. And by the way, if you do it this way, ladies and gentlemen, you're setting yourself up very well to do this problem down here very easily. Because you've not only got the whole, but you found each part as well. Okay? And that's what you need to do. The part divided by the whole times 100. Or we could multiply it by 3 if you would prefer. What do you think? Should we do that? No, let's not.
Let's
Okay.
make it harsh.
Again, we're not working with moles here at all. All we're doing is percentage. This could be the percentage of anything. A percentage of anything is a part out of the whole. Okay? This has absolutely nothing to do with what?
Moles.
Moles. Nothing to do with moles. Okay. So, if we're going to find the percent of magnesium, we're going to take the mass of magnesium divided by the formula mass of the compound. If we're going to find the percentage of nitrogen, we take the mass of nitrogen and we divide it by the formula mass of the compound. And if we're going to take the percentage of oxygen, we need the mass of oxygen divided by the, yes, thank you, formula mass of the compound. By the way, which of those never changes?
Of the compound.
Of the compound. Thank you, thank you, thank you. Everybody good with this part? Good. Let's put some numbers in. 24.31 divided by 148.33 times 100 gives us 16.4. 28.02 divided by 148.33 times 100 gives us 19.0. 96.0 divided by 148.33 times 100 gives us 64.7. There's your percent composition for every component of that compound, ladies and gentlemen. Percent composition is simply a part out of the whole. Ladies and gentlemen, this is going to be my final warning to you. Those of you who insist on bringing jackets to class, they go in your backpacks or they go out the door, or from tomorrow I'm going to send you back to your locker and you're going to be late coming to class. Do one of the 3. I'm giving you 3 options, but them sitting on the back of your chairs while you're sitting on them is not one of those options. and I don't want to hear any more whining about how cold it is in here. I wear a same short sleeve t-shirt every day, and if I get cold, I have a sweatshirt to wear in case of it. Figure it out. I'm done with it. Questions, ladies and gentlemen?
Would there be a problem where you have to do the percent composition, then do the other stuff?
Convert it to moles?
Conversions to moles.
No, you know why?
Because
we already know what it was in moles. It was 1 magnesium to 2 nitrogens to 6 oxygens. This is the exact opposite of what we've just been doing. The exact opposite. Matter of fact, when you have these numbers, ladies and gentlemen, you could go back and you could find the moles. That's how they do it. That's how they get those numbers that end up being, okay, what's the molar ratio in this? When we take these, make them into grams, and then go the other way. All we would be doing is the exact same thing in the opposite
do we have
direction.
this problem on our test this Friday?
There will be a problem like this on your test this Friday, yes. Just like this. Just like this. Anyone need more time with this slide? Okay. Aluminum sulfate, ladies and gentlemen. Aluminum sulfate is Al2SO4 in parentheses 3. Has a formula mass of 342.17. That comes from 2 aluminums at 26.98, making 53.96. 3 sulfurs at 32.07, making 96.21, and 12 oxygens at 16.0, making 192.0. Add those all together, that's how I get the 342.17. To find the percent of aluminum, we take the mass of aluminum divided by the formula mass of the compound. To find the percent of sulfur, we take the mass of sulfur divided by the formula mass of the compound. To find the percent of oxygen, we take the mass of oxygen divided by the formula mass of the compound. Questions? Anyone need more time before I move on? So we take the 53.96 divided by the 342.17 times 100. 15.8% of this compound is aluminum. 96.21 grams of sulfur divided by the 342.19 grams of the compound times 100 means that this compound is 28.1% sulfur. And finally, ladies and gentlemen, 192 grams of oxygen divided by the 342.17 grams of the compound times 100 means that our oxygen is 56.1% of our compound. What should those three numbers total up to be very close to? 100. Just as a double check for you. Just as a double check for you. Those should come out to be 100. In this case, they come out to exactly 100. Again, 99.8, 99.7, 100.1, 100.2, 100.3, fine. Rounding errors will cause that to happen. But again, ladies and gentlemen, you should be very close to 100. Questions? Ladies and gentlemen, I think I'm a dang good teacher, but I don't think I'm this good that there shouldn't be any single questions in this class. You're scaring the heck out of me right now. But your choice, ladies and gentlemen. Your choice. Okay. Here's your packet, ladies and gentlemen. By the way, I'm not collecting it. Why? What does homework count toward your grade?
It's not weighted. Nothing.
It doesn't. It doesn't. So somebody, and I think maybe it was Michaela or somebody said earlier, well, what about all these ones on here? Do as many of them as you need to. Do as many of them until you feel comfortable doing these problems to where on Friday's test, you feel comfortable that you're going to get the correct answers. If that means doing one problem, do one. If that means doing the whole worksheet, do the whole worksheet. I'm not collecting them. Okay? Not putting it in the grade book. Okay? But understand, there is ample opportunity here for you to get some things done. So, on this problem where I ask you to convert from grams to moles, you're going to have to do that on the test. You need practice? Here you go. Here's where you can practice it. Okay? You want to convert to volume, from moles to volumes, from particles to volume. Here you go. Here's where you can practice. I am not going to make a single one-step problem on your test. There is no moles to mass, mass to moles, moles to volume, volume to moles, particles to moles, moles to particles. 4 two-step problems at least. Mass to volume, mass to particles. Particles to volume, particles to mass. Volume to mass, volume to particles. That's 4 questions on your test, 6 points each. You need practice? Here's your practice. Hey, guess what? There's answer keys online that can help you as well. Or, you know what? I'm here. I'll help you. I'll go over it with you. I'll show you how to do it. Formula determination problems. There will be one problem, like numbers 1 through, I think, 5 on here. 1 through 4. There's going to be a problem like this, 1 through 4, on your test. You can do these, great. Not, you better figure it out. There's practice here. By the way, for number 5 all the way through number 10, ladies and gentlemen, except for finding the molecular formula, you would do the exact same thing on problem 5 that you would do on problem 4. You would take what you're given. If it's a percent, you make it into grams. If it's grams, you use grams to go to moles. By the way, what we just did is how they got these numbers. That's percent composition. It's telling you that the compound is 58.54% carbon. We just showed you how to find that. Now we've got to go the other way. Now we've got to go from percents into moles, because now we need a molar ratio. Okay? And we did not do a lot with the molar mass. We showed you how to do it. We talked about it. Here's some practice problems, 5 through 10 on this worksheet. Our practice problems for how to find the molar mass. But probably 85% of this problem is the same as the one above, finding the empirical formula first. And then taking that empirical formula and figuring out how to use this to find the molar mass and the molar formula, molecular formula, I should say. There's plenty of practice for it. And hey, looky here, ladies and gentlemen. Here's a compound. Write the formula, figure out the percent composition for it. That is everything you need to get ready for your test. Now, how much time you're going to spend, how many of these you're going to do, that's on you. How many do you need to do to get to the point where on the test, you could pick any one of these and do it without the answer keys? You're to that point already? Awesome, excellent, wonderful. You are way ahead of schedule. If not, here's some opportunities to practice it. So, go ahead, Michaela.
I have a question on like how you get to formula units to atoms.
Okay, I'll be there in 1 second, okay?
Yeah.
Okay, so here's what I'm telling you. This is one of the 3 major problems on your test. This is one of the 3 major problems on your test. And this is one of the 3 major problems on your test. You can't do these, you're in trouble. Okay?
Empirical formula, molecular formula.
And percent composition. Those are 40 out of the 73 points on your test. Questions?
Oh, you're okay.
All right, you have got about 10 minutes left, I believe, if I'm correct. We get out of here at what? 30. Oh, no, you got about 15 minutes. Go to work, ladies and gentlemen. There's something you want a hand with, please let me know. Okay? All right, Michaela, let me turn on the lights and then I will come over and I will help you. Okay? Okay. All right. So here's the thing, Michaela. Formula, the particles for 6.02 affect centers and 23rds is determined by what the smallest piece of the substance that is there is. Okay? So if your substance is a compound, like N2, because it's nitrogen gas, it's N2. That means the smallest part is a molecule. Okay? Because N2 will not be nitrogen alone. Okay? If it's CO2, that is a molecule. Okay? If it's NaCl, that is a formula unit. And if it's something like gold, then the smallest part is an atom. Okay? So if it's an element, the smallest part will be an atom. If it is an ionic compound, the smallest part will be a formula unit. And if it is a covalent compound, the smallest part will be a molecule. But this molecule of nitrogen gas, N2, is made up of 2 atoms of nitrogen gas. So that should be 2 atoms in 1 molecule. And that's how you get your final answer.
Oh, okay. And that's confused because I thought on the sheet.
On one, it did say 3, but I think we're looking at version B, because version B, the compound was CO2.
Yeah.
Which again is a molecule, but the difference there is 3 atoms would make up that 1 molecule. Correct. Yep. Okay. Does that help?
Yeah.
Okay. Any other questions?
No.
Okay.
We just do it at Monday. I have to pee for the last 2 minutes. That sucks.
Hang on one second.
This is the bird of the day. He's so goofy. I spit everywhere. You do that a lot.
Yeah, because there's not another question in the school that has that except for this one is the one next to it.
Why did you give the same price?
But yep.
Righty.
Oh, left.
So I got all of it. Because this stuff, adorable problems. This stuff I'm good.
Okay, so slow down because right now I'm getting ahead.
I'm sorry, I got a headache last week, so I just thought.
Okay, so this is correct.
What is
This became a masterization.
Calculate. I don't know where the
So
assignment
that's
is.
what you do know where you have that. 65.3.
They're so good, bro. Like, I don't know. Like, and I can't find the Hey,
Now do the math.
where does it start? It does.
I will get back in one. Yeah, go ahead. I'll be back in 1 second. I'm gonna stop the recording and I'm doing it.
Let's just do